We are going to talk about factoring today. So let's start with finding the greatest common factor of a pair of numbers. So I'm going to make a factor tree for my numbers. So I can break 64 down into 8 times 8, and then 4 times 2, and 4 times 2. So I end up with 64 has 6 factors of 2 for its prime factorization. 24, I'm going to do 6 and 4. I could have done 8 and 3, 12 and 2, but it ends up as being 3 times 2 times 2 times 2. I think that was the right number of 2's. So the greatest common factor is the largest number that evenly divides into both. So if I look at the shared factors, they share a factor of 2, they share another factor of 2, and then they share one more factor of 2. Now I'm out of factors that they have in common. So my greatest common factor is going to be 2 times 2 times 2, or just 8, which you might have known when you looked at 64 and 24. The biggest number that divided into both of them was 8, but if you didn't, that's a way you can find it. So when I'm factoring a polynomial, that means I'm breaking it down into factors that multiply together to get you your original polynomial. Factoring it all the way means I'm breaking it down into prime factors that multiply together to get you my original. When I'm factoring a polynomial, I always want to factor out that greatest common factor first. So let's factor this one. To make it a little easier to see what the greatest common factor is, I'm going to write it as like 7 and then t times itself 5 times, and then if I break down 14 into 7 times 2, and then I'm going to write out 8 factors of t. I'm actually going to copy and paste here. So you don't have to do this every time, but it helps you to see what they have in common to start with. So they share a 7, they share a factor of t, another factor of t, another factor of t. Eventually I'm going to run out of factors that they share. So my greatest common factor is 7t to the 5th. And then I have some things left over that are not common factors. I can always think of there being a factor of 1. There has to be something left over. So I'm going to factor out that common factor of 7t to the 5th. And then for my two terms that I was factoring things out of, my original 7t to the 5th and my original negative 14t to the 8th, just got a minus in between them still. After I've factored out my common factor, I'm left with 1 minus 2t to the 3rd. You can kind of check yourself by multiplying it back together if you wanted to, and seeing that it equals the original, and also that 1 minus 2t to the 3rd doesn't share any other factors. I just rewrote it so it'll be a little bit neater. Let's look at another one. So if you look at these three terms and think about what factors they have in common, I'm going to think of 24 as 12 times 2. Instead of breaking it down all the way, I'm going to notice right now that all of those have a common factor of 12 that I could factor out. And also they have one factor of y. I can't factor out more than one factor of y, or my last term of negative 12y runs out of y's that are shared. So for those three terms, once I've factored out my 12y, let's look at what's left. So that leaves me with a factor of 2, and then 2 more factors of y, because I had 3 to start with, and I divided out 1. My middle term, I just have a 1y left. My last one, I have a 1, which, if you kind of think about what you're doing when you're factoring them out, you're basically dividing each term by 12y, which leaves you with a 2y squared for your first term, and then 12y squared divided by 12y gives you a 1y for your middle term, and 12y divided by itself gives you 1 for your last term. So you can think about it that way too, if you prefer. So that looks nice and factored. Let's look at one where there are multiple variables. So I'm going to go ahead and write out everything on this one. All of my factors. You don't have to if you don't want to, but I'm going to. Run out of space, scoot it over. Okay, and then if you think about what factors are shared by your three terms, they all share a factor of 2. They all share a single factor of a. Then the first one has no more a's, so they also all share a factor of b, but then my middle terms run out of b's. So my greatest common factor that they all have in common is 2ab. So I'm going to factor it out. And then if I think about my three original terms and what's left after I factor out that common factor, my first term of 6ab squared has a 3b remaining. My middle term, think about, well, you're really dividing by 2ab, so you still have a factor of 1. And my last term, I have a 2ab to the 6th, if you count all those factors of b up left on that one. So I want to show you for a second what happens if you don't get the greatest common factor factored out. Say that I don't make a factor tree for 36 and 9, and I think that the biggest number that divides into both of them is 3, and I see that these share a common factor of a as well. So I could factor out a common factor of 3a. It's not my greatest common factor, but I can do this in multiple steps. So if I factor out a 3a first, that's going to leave me with 3a times the quantity 12a plus 3. And then if you look, 12 and 3 both still have another common factor. They have a common factor of 3 again. So I could factor out another factor of 3 from 12a and 3 and put it on the outside with my common factor that I did earlier. And that'll leave me with 4a plus 1. And then I just multiply 3a times 3 on the outside and get 9a times the quantity 4a plus 1. If you would have factored out a 9a to start with, you would have ended up at the same place, but just check and make sure there's no remaining common factor when you're all said and done. So what happens if your terms don't all share a common factor? Sometimes you might have things that don't have a factor in common, but maybe smaller groups of them do. So if you have 4 or more terms, you might be able to factor using a method called grouping. Essentially, instead of trying to take a common factor out of everything, you break your terms into smaller groups and then factor out a greatest common factor from your groups, and we'll talk about what happens from there. So you looked at this expression a second ago. There's no common factor of all of my terms. Like the 3 on the end there is missing an x, so I can't factor out an x. Not everything's divisible by 4, not everything's divisible by 3, so there's no common factor of all 4 terms. But I can make some smaller groups, so say I look at just the first 2 terms and the last 2 terms separately. Those first 2 terms share a common factor of 4x, so I could take that and factor a 4x, and that would leave me with an x squared plus 1, so I rewrote it with a 4x factored out. And then if I take those last 2 terms, still have my plus in the middle here, I'm just rewriting this in a different way, I could factor out a 3, and it would look like 3 times x squared plus 1. And then if you notice, from the way that we've rewritten this, you have kind of this set of terms being multiplied in green and in blue. And in that set of terms, each of them shares a factor of x squared plus 1. So I can factor that x squared plus 1 out of my whole entire expression, and that'll leave me with, if you look at what is left in your blue expression and your green expression, you're left with a 4x from your first set of terms, and then plus in the middle, a 3 from your second set of terms. So if you were to multiply that out, it would actually equal your original polynomial. So that is factored. And if you notice, when we looked at these earlier, those are all exactly the same expression. It's just one of them is factored all the way, one of them is partially factored, and one of them is written all multiplied together as a polynomial. Let's look at another one. So you can group these in any way that you like. Like, it doesn't have to be first 2 terms, last 2 terms, as long as your groups have something that they have in common. I just like to do first 2, last 2, because that means I don't feel the need to rewrite it and rearrange it. So if I take those first 2 terms, I can factor out an 8t squared. If you look at the last 2, it doesn't look like they have anything in common, but they actually share a factor of -1. And you could always do a factor of +1, but I need my signs to match so that I have a group of 3t plus 5, which means I need to factor out a -1, because if I divide by a -1, it'll flip both my signs and it'll still equal the original. So then you have that common group of 3t plus 5, which you can factor out, and that'll leave you with 8t squared minus 1, which if you were to think about multiplying that back together, distributive property, it would equal your original.